we've used a table to find a limit, let's use a graph to find a limit. Find the limit of f of x as x approaches 3. So we have f of x equals 2, but x cannot be 3, and f of x equals 0 when x equals 3. So first of all, it's being able to graph these first of all. So f of x, so let's just say, remember another word for f of x is y. So y equals 2, but x cannot equal 3. So what this is, the first line is a horizontal line that goes through 2, but it cannot equal 3, right? That's what that means. So here is the graph of the first one. Then on the bottom one, we say that y equals 0 when x equals 3. So therefore that is a point at x is 3, y is 0. So it is a point here. So this question is asking us to find the limit of f of x as x approaches 3. So we're trying to find what is the y value that this function approaches as the x approaches 3 here. And so notice that our y value is always 2. Now it doesn't really matter here that there's a hole here. For the most part, if we follow this line, this is on the y value of 2. So this limit as x approaches 3 of this function is just 2, okay, because it's coming from the left and from the right, and that's the value we have. So try this example here. Find the limit of f of x as x approaches 2. So if you drew this out, you would see that the y equals -3. So there is a line at y equals -3, horizontal line, but it cannot equal +2. Then at that 0, x is 2. At the 2, y is 0. So we have a point here. So we say that the limit of f of x as x approaches 2 is -3. Okay, it's that y value here. In example 5, so the first one we did, the fact that f of 3 equals 0, it has no bearing on the existence or value of the limit as x approaches 3. So for example, if the function were defined as f of x equals 2 and x cannot equal 3 and 4 when x equals 3, then it's still the limit as x approaches 3. It would still equal this 2 here, okay? So it's similar to the other problems we had. I know this is very different, but just to kind of look at it. So let's look at another example, and this might help it a little bit more. Limits that fail to exist. So example 6, we're comparing left and right behavior. We're going to show that the limit does not exist. So we have the limit as x approaches 0 of absolute value of x over x. So first, let's just plug in some numbers algebraically. Let's plug in some numbers that are less than 0, right? So it's all going around this 0 here. So a number, we can't plug in 0. Notice if we plug in 0, we get 0 over 0, and so that doesn't work. We know that it's not going to hit this here, so it's going to be like an open circle when we draw it on that y-axis. So let's pick -1. So let's pick some whole numbers. And if we plug in -1, so just remind me what I'm plugging in, I have -1, absolute value of -1 over -1. So it's going to be 1 over -1 or 1. Let me try one more number. Let's try -2. So I plug in -2, absolute value of -2 over -2. I'm going to get 2 over -2, which is a -1. Sorry, this is also a -1. So notice that when x is less than 0, if I keep on plugging in numbers, it's just going to be at this -1 line on this side. So it cannot equal 0, but if I pick numbers to the left of that 0, it's going to go to the left at -1. Now let's pick some numbers that are greater than 0. So let's pick +1. And so if we plug in +1, we get 1 over 1, which is 1. Let's pick 2. So if we plug in 2 over 2, we're going to get 2 over 2, which is just 1 again. So notice, to the right of that, when we're picking numbers larger than 0, it's always going to be +1. So what I'm going to write is that so if we have absolute value of x over x, that's going to always equal 1 when x is greater than 0, right? So over here, it's when it's greater than 0. Then when it's less than 0, so absolute value of x over x, that is going to always equal -1 when x is less than 0. So notice they're not approaching the same number. And so because they don't approach the same number from the left and the right, this means the limit does not exist. The limit does not exist. And then you'll see that as D and E as well. Does not exist. So try this example, show that the limit does not exist. So I do want you to graph it and then plug in a few numbers to kind of help you out and try this out. So you notice if you plug in numbers that are greater than 1, you're going to get that the value is going to be 2. Then if you plug in numbers less than 1, then you're going to get -2. So notice, number 1, this is where the open circles are. Here is at the 1, right? So as x approaches 1, because you notice if you plug in 1, you're going to get 0 over 0, which is not good. And then, or you can't add that. And then notice on the, if you pick numbers to the right of the 1, it's going to be at y equals 2. And then if you plug in less than 1, like 0 and so forth, you're going to get -2. So because we're approaching different numbers from the left and from the right, the limit does not exist. And so I am kind of introducing that we can write it in this way. The limit of f of x as x approaches 1 from the left equals -2. And the limit of f of x as x approaches 1 from the right equals +2. Therefore, the limit does not exist.